Hello everyone, I'm Nathan. I'm really happy to be here today to talk to you about zero knowledge and zero-to-knowledge virtual machine and how they can help you build compliant application on the blockchain and mostly on the XRP Ledger. First of all, a little disclaimer. This is about zero knowledge, but I won't talk at all about mathematics. So this is a session for everyone, and I hope you'll enjoy it. Just a little bit about me. I'm a teacher in some French engineering schools, and I'm also a co-founder of Cypher Lab, a company focused on building open source cryptographic libraries to improve privacy in the blockchain space and beyond. I divided this talk into two parts. The first one will be about what is a zero-knowledge proof, a zero-knowledge virtual machine. We will also build one together. And then I will give you some examples of real use cases. First of all, what is a zero-knowledge proof? Unlike any other proof you can find on the internet, like digital signature, zero-knowledge proof allows you to never give any other information than what you want to prove. Let's say I have a secret. I don't want you to learn anything about the secret itself or about me. I can use a zero-knowledge proof to do this. Currently on the blockchain, we are using a kind of digital signatures that force the receiver, the verifier, to know something about you. They will know your address, your public key, and then they can find every information about what you did on the blockchain previously and in the future. And this is not what we want. OK, a little bit example. This is what we call the free colorability problem. It's a problem encountered by geographers when they want to draw a map and they don't want to have two adjacent countries with the same color, because for readability reasons, of course. This is a really complex problem to solve with mathematics, and it's even harder to find a solution. So today, I will prove to you that I have a solution to this problem without revealing it. To do so, actually, I have two ways of doing it without zero-knowledge proofs. I can either show you the solution like this. You can see the solution here, but you can see it, and I don't want you to know it. Another solution would be picking some random guy in the streets and asking him to verify that this solution is valid, and then he will testify in front of you that this solution is valid, without you seeing it. But actually, this requires trust, because I have to trust this guy that he has not been paid by you to reveal the solution later on. Or maybe you don't want me to pay this guy to say, yeah, this proof is valid, whereas it's not. So to create a zero-knowledge proof out of it, I will first do what we call the randomization of the solution, which is here, shifting the colors. So I can switch like yellow for blue, blue for yellow, and the red dots keep red. And now, you can open your eyes now, and then you see the solution which is hidden. To prove to you that I have a valid solution, I will just ask you to point two different adjacent vertices, and you will see that they don't have the same color. Let's say you choose those ones. Those adjacent vertices don't have the same color, but are you convinced? No, you can't be convinced out of this. Because if you look at it, I have 9 segments that have not been discovered yet, and maybe there are two vertices with the same two adjacent vertices with the same solution, with the same color. But I can't show you more vertices, because otherwise you will be able to know something about the solution and maybe to reconstruct the solution itself. So the solution to this is restarting it all from the beginning. I will re-randomize the solution. I will hide them again and ask you to point two other vertices in order to prove to you that they are not the same colors. And again, I still have 6 chances out of 8 not to be caught. But if we do this and we repeat the process, let's say 1,000 times, you have more chances to win 10 times the lottery than me being a cheater. The probability will drop very fast, and you can be sure, like almost 100%, 99.99999 and a lot of 9 behind it, that I'm not a cheater. More generally, when we want to create what we call a zk proof, we are using a zk circuit. A zk circuit can be seen as a really complex mathematical function which will take your public input, which is the data you will share with the verifier, and the private inputs, which is the secrets you don't want to show the world. And the secret secret will take this information and create the proof, which is nonsense for you, but actually when you put it into the verifier, which is another kind of circuit, you will be able to verify that this proof is valid or not. ZK circuits are have a single purpose. You can't use the same circuit to prove that today you are here at Apex and that you're from Europe or Asia or wherever you want. You will need another circuit which can take up to, let's say, 9 months just to verify a single electronic signature. On top of these circuits, we recently, like 5 years ago, added what we call zero-knowledge virtual machines. It's a new layer of abstraction allowing you to, as a programmer, write any code in a lot of different languages, but mainly Rust for now, write a script, whatever it is, and then execute it and prove that its execution went well. The idea behind it is that you can create a really complex script, which can take like thousands of lines, and you don't have to build a specific circuit for this script. The zero-knowledge virtual machine will build the script, the circuit out of the code, and whenever you run the code, you will just get what we call the execution trace, which is each step your computing units executed. And from this trace, you will be able to prove that the execution went well without revealing whatever happened in the codes and whatever were the private inputs. But why am I talking about zero-knowledge now? Because zero-knowledge are almost 40 years old now, and no one really used them before the blockchain arose. Like 13 years ago, when the blockchain arrived, we added this very famous sentence, like, don't trust, verify. And this is exactly the spirit of zero-knowledge proofs, because whatever we are doing with zero-knowledge proofs right now, they used to be done using trust, because trust was all we needed. When you wanted someone to prove that he has, let's say, a 1 grand in the bank, you just asked for documents from the bank. And you trust the bank because it's the bank. But what if the bank is lying? What if the document is a false one? Using zero-knowledge proof, there is no question like this. Like, it's valid, so OK, I can trust it. That's it. For example, in terms of research, 3 years ago, we took something around 2 to 3 hours to verify an Ethereum block using a zero-knowledge virtual machine. And a month ago, Succent, with their SP1 virtual machine, successfully proved an Ethereum block in less than 12 seconds, which means we are this close to reaching the live proving. What is live proving? On the blockchain, for now, you need to have a whole copy of the blockchain to make sure the new block is valid, that the consensus is respected. But you can do it on your phone right now. Using zero-knowledge proof, you will be able to verify each block on the blockchain without having the whole blockchain. You just receive a small proof and the state transition. That's it. And you can verify it in a few seconds. But since the zero-knowledge proof are now up, working very fine, we can think of new use cases and some places where zero-knowledge proof can just replace trust, actually. The first thing that can come in mind is identity verification. Because I can prove to you that I'm here today. I can prove to you that I can drink alcohol, I'm over 21, without having to reveal any information about me except that I'm above the legal age. And this is huge. This is huge because the barman don't need to know my name, don't need to know my address, my country of residence, or whatever information about me. It can also be used in compliance, which is like all the sequence here, to prove that you are compliant in a lot of businesses. I took finance, but actually you can use it in a lot of different sectors. Okay. The first example here and use case is the anti-money laundering compliance. The idea is to be able to prove that you are compliant regarding the AML laws in your country without disclosing any information. Because for now, you have to disclose like all the transaction data you did, all of your risk scores, all of the client identities. And if you think about it for a little, it's all your business. Like you are giving all your business to the state, to the regulator, to prove that you're not a bad person, a bad business. And this, if it leaks to any other concurrents or anyone else outside the regulator. They can just use it to build a new business and maybe take some of your clients and some of your business. So you don't want it. To fight against this risk of leak, you can use what we call zero-knowledge virtual machine in order to prove that your clients are compliant, that they have like all the background of the money have been checked, all your transactions are compliant regarding the flags that should be raised if there is anything suspicious. And it's also a huge win in terms of human energy and human time, because you won't need to build all those documents, the ton of documents that you will end up to the regulator, but just you generate automatically a simple proof that everything is valid, that everything is fine. Of course, if the regulator needs it, he can ask you for some additional documents or some additional proof which are more specific. But you can give those documents. You're just protecting yourself against the loss of all the documents. Another example are what we call solvency proofs. As a crypto exchange, as a bank, as a company doing financial stuff with the funds from your clients, you have to be able at almost any time to prove that you still have at least the amount of assets that have been lended to you. By doing so, you have to disclose their location, their amount, and everything, which might lead to a loss of competitive advantage and privacy as a company. So you can really easily just create a simple proof proving that you have assets in this bank, Oh, I have these tokens also. I have these arms somewhere. But you don't know anything about the assets themselves. You don't know anything about where they are. You just know with 100% certainty that these assets are available at any time and that the business can just give them back to the clients without further information. Zero-knowledge proofs are really useful with blockchain also, because all those proofs can be timestamped using the immutability of the blockchain, just to make sure that at this specific moment, I have this information. So of course, I can just share the proof itself on the blockchain, but if I want it to be more private, I can just put fingerprints of the blockchain, like hashing of the blockchain, on the proof on the blockchain directly. Another example is what we call insider trading, against insider trading. The idea is to prove that at any trade your algorithm took, there is no information from private source of information. It's all publicly available data. It's all mathematics. So you can prove at any time that your trades are valid regarding the regulator. But this also works for any algorithm that is running automatically on your servers. You can generate proofs, keep them from yourself, and if needed, you can just show them to the regulator. The proof generation time is now really okay. It's like a few minutes, depending on how much computation has been done, but the proof itself is really lightweight, so you can store it everywhere. Another example here is what we call private transaction validation, which is already live on the blockchain, actually. You have a few blockchains giving it, but most of the time it's not compliant regarding the law of the country, especially the SEC and Europe. But it's live and it works. For cross-border payment and cross-blockchain payments, you can also use such things, but with more advanced cryptography, allowing you to prove that, for instance, if I want to send money in another country, I can prove that my funds are compliant. They are from some valid sources. It's legit. But also that the receiver is not blacklisted, is not in a restricted country or whatever kind of regulation that might apply to him, allowing him also to receive the funds. I can also avoid leaking the amount. I can hide the amount in a zero-knowledge proof and later on prove that I did this transfer with the disclose of the amount if needed. And the last thing is still the privacy, because when you are sending money through the banks, you will have a lot of third parties which will be able to see the information of your trades, things about you, things about the receiver, about the amounts, and you don't want this. If you don't want this, you can just hide them all in a zero-knowledge proof, prove that you did a transaction, and at any time you are able to say to the regulator, hey, look, okay, I did a transaction, but this one is valid. You can check it here. And also, if needed, you can prove that the receiver, you can prove the identity of the receiver or the specific amount you send. Another live application you can use right now if you have an Android phone is Google Wallet, which is using them. You can use them to prove your identity or things about you without revealing any additional information. It's brand new. It started like a few months ago. So if you want to check, there is an article here. Anyway, zero-knowledge proofs are a real new paradigm, which is starting to be discovered for now. But in the next 2 to 3 years, I'm 100% sure we will all be using zero-knowledge proofs without even knowing they are zero-knowledge proofs. Because it's saving so much time and effort to all the paperwork you might do, all the things you might do, even on your phone, on the bank, or wherever you want. And I'm pretty sure this is the future. So thank you for listening. We still have a few minutes for questions, so if you have some, you can just stand up and raise your hand.
Thank you, thank you. The problem with compliance, normally the regulators, if I am a compliance manager, regulators ask me to give him all the data about the user, not that he is compliant, but please provide me the proof that you know everything about him, that it is compliant. So he requests not the proof that my client is compliant, but he asked me to provide him the data about my client. And if I don't know the data, what I can provide to him?
Sure. You can wrap it up in all-in-one proof. So you have all the information about your clients. So you can prove that this information is really from this client. And you will just say, OK, look, this is the information from the client. You can verify from the zero-knowledge proof I gave you. So you don't disclose any additional information about your client except what the regulator is asking for.
So what do you think the timeline is to have this kind of actually on XRP where you could actually do these a transaction like that and incorporate the zero-knowledge proofs?
The first trick we can use already right now is the timestamps and the immutability of the ledger. So we can prove that at this specific time, you had this proof published. Another use case which will come, I hope, is an amendment from Marco Neri talking about verifying zero-knowledge proof directly into the ledger. So as an application, you can just prove that your transition is right regarding the codes you specified when you published the verifier on the blockchain. And you can prove that everything you did is right, simply. Like for scalability reason, we still have, we already have it on EVM, for instance. When you want to prove that your layer 2 did well and went well, you want to publish the proof on the layer 1. And this is exactly what could happen with the XRP Ledger. But not for blockchain, or for blockchain if they want, but also for any businesses or application that is open to the public, and I want to show that everything is fine on their side. Thank you for your time and attention.